I would like to ask your permission if I could record this lecture also for reference for your future exam and other activities. So it's better to record it so that you have a copy. And if you forgot something and if you need to review another subject, so you will have this recording available in YouTube. And uh, do all agree that I will have this recording?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you. So we start. So this is just today we won't have a laboratory since we have already too many things to do for this week, and also the deadline and also the test will be on Friday. So uh Wednesday I'll just have going to give you uh, a short lecture, and I'll give you time to study for the test on Friday. And Thursday, also maybe 30 minutes. But this one, I would like to finish all of this topology. Then we move forward to finishing our lecture already in subnetting and subnet mask. Now, since we don't have enough background, so I would like to ask you to just have some review on this part. And also, I'll attach the material for or the book that I'm using for this lecture. Okay. So for the PowerPoint, we move forward. So these are the other network devices that we use. So last time, we already have some example of the switch, and now we have this wireless AP, or this is the heart of your wireless access point. So it's a lot like a hub, but this it can send signals to communicate to other computers. The obvious difference is that the signals don't travel through a physical medium. They travel through the airwaves, such as radio signals. So, for example, a wireless access point operating at 11 megabit per second shares his 11 megabit per second with all computers in the wireless network. Therefore, if there are 11 workstations that are connected to a 11 megabit per second wireless network, each station will have 1 megabit per second effective bandwidth. So in this case, so that's why if you have a limit in your home router, so this is in the same way if you have wireless router at your home. So that's why if you have so many people connecting on the internet, so there are chances that in the same case it would not allow other to access because there's also a limit. Now, for uh, mostly these access point are basically used in some small businesses. And how do we extend wireless routers capacity to other offices? How do we extend? This is your what we call this packet traces access point is basically your repeater, right? This is your repeater, and this would just provide you with a wireless connection. So no LAN. If you want to connect to LAN, so you will have a switch. Now for this, this is an example of your home router, As you can see, if you have a PLDT, DSL, and other ISPs in Philippines, you have this home router usually used. And when a wireless network bandwidth is shared, it works as a hub. Now, for the uh, second device, you usually have the network interface card. So mostly the terms that we're going to use, we call it NIC. It is the card that is being attached to your computer that allows connection between the computer and the networking medium. So the network medium might be a copper wire, a fiber optic cable, or in the airwaves. And usually, in all cases, the data is represented as a bit signals that transmits or receive. Now, for it's also provide other information, and it's more slide. Okay, here. It's also provide network to other network. It provide internet to other network, and for incoming messages, the it receive bit signals and assemble them into frames and verify the name's destination address, remove the frame header and trailer, and transfer the packet into the network protocol. Later, we will have a example of this in few slides. So don't worry about how the data is being converted into these frames. And also you have the frame header and trailer. And for outgoing messages, we receive packets from the network protocol and create frames by adding source and destination to your physical address or your media access control address. And error checking data is made. And after that, it's convert the data frame into bit signals and in a format suitable for the network medium to transmit the signals. Now, this is an example of incoming data. So example, there are incoming bit signals on the network medium, and these were in what type of numerical values. These are,
Binary digit, sir.
so they are your
Binary.
binary signals or your bit, binary digit. So that is your bit. You have your destination physical address. This is your frame header. This is based on the incoming data from your network medium and your source physical MAC address. So destination and source. And you have your destination IP and you have your source IP. So that's why last time we tried to communicate to other computer. As you see, you could see the destination and also the IP of the computer that we are having to connect. And also the source physical address is also being uh, inside this data. So this is coming from your network interface card. So that's why a network interface card is very useful because it converts big signal into frame, and it verifies the MAC address and remove the frame header and trailer and sends the packet to the network protocol and verifies the CRC. What is the CRC? Anybody? CRC is cyclic redundancy correction. So you check every bit 1 or 0. If it is bit 1, then good, and bit 0 is false. And for your network protocol, so where is your data is being put? So it is on your ICMP echo request. So after the NIC, so you're going to forward it to the packet which contains the network protocol, and this time it identifies the destination IP and the source IP, and it contains your data. So now frame header and trailer were removed, right? And what is left to be sent is this area. So that's why when the frame header is identified, so this in this case, this was your packet signals that being sent to your network protocol. And for the next slide, you have the outgoing. So this is your outgoing data from the network medium. So you have another bit of information then converted into hexadecimal values, and you have this as your destination MAC address. And now you have this as your frame header. Once you going to receive the information, so before we send the information on the incoming, on this arrow on the packet, now we send the information to uh, the next computer. So this now the network protocol and packet was being received from the network protocol. So this was sent by the network protocol, and it adds the header. This is the header after the network protocol send the the packet. This is the packet. You the source and destination MAC address will be added as your frame header, and the frame trailer also. And it converts the frame into bits of transmission medium, transmission onto the medium. So this is the bits of information being transferred to the computer. So that's how uh, network interface card handles incoming and outgoing data from the network medium. So although it is fast, right? How many milliseconds did you try to implement in your packet tracer? How many? Sometimes it reaches 0 milliseconds or negligible, or we have last time tried to see, we observed that we have 4 milliseconds. Only two computers. But if you add more, it would be different. Later, we have some, not really an activity, but we try to see if Pocket Tracer could be able to simulate these methods. Okay, so we have routers. So routers are basically one of the important devices that we have in order for network to send data. So it enable multiple local area network to communicate with one another by forwarding packets from one LAN to another. They also forward packets from one router to another when LANs are separated by multiple routers. The internet is built on a vast collection of LANs, all interconnected via routers. Now, the routers work with IP addresses and routing tables. So on the next slide, we will have an example of a routing table that will be used mostly in our next topic. So switches, as you know, maintain switching table of physical address and the switch port pairs to determine where to forward frames in a local area network. Now, routers maintain routing tables composed of IP network addresses and interface pairs to determine where to forward the packets in an internet network. Now, routers have two or more interfaces. So with each interface, it is connected to a different network. When a router receives a packet of one interface, it looks at the destination IP address. So when it receives, what will happen? It looks at the destination address and what else? So, and it determines where the address is going to. So we have the source address and forwards the packet out of the interface. That is, its routing table indicates it's the best way to get the packet to its destination. So inside this, there is a routing table that allows us to determine where we're going to send those packets. Okay, so have you seen a router at your home?
Yes,
Wireless
sir.
router. So this, the following in the figure are like a high-end router. These are used basically for gaming. So in some countries, they don't usually use wires, and because wireless connection in their country are high speed, so you could play games wireless in other countries with no cable at all, and these are in gigabit per second speed. So these are modern routers that is really expensive when you're going to buy it in Philippines. And also, we have okay. So I think we are. Any question on routers? Okay, so we move to the next. Now, this is what I'm telling you. So, how we're able internetwork in a routing table. So, this is the routing table in the router. This is your marketing server example, and this is your management server. This is your marketing LAN. This is a group of computers connected, and this one is also connected to marketing. In this area, this the management group, which having a network 3.0, and this one is on the development LAN. And what symbol is this? Anybody? What symbol is this?
Switch, sir.
Correct. This is a switch. Thank you. This is a switch. This is a router, and this is your server. Okay. So the network medium might be a copper wire or a fiber optic cable and the airwaves, but in all cases, the data is represented as a bit signal that is the NIC transmit or receive. In this diagram, it's a switch, okay? So what is the symbol for repeater? It's your access point. That's the symbol. This one is a switch. This one is a switch. This one is a switch. Because you have so many computers to connect. Like if you have marketing group, how many computers are in the marketing group? So using access point, you could use also access point if you have wireless connection. And this, the incoming messages receive bit signals and assemble them into frames. And may harap pa nagsulod. Very late. Okay. Okay. So for incoming messages, like this one before, this is incoming data. So the messages sent here and frame header, frame trailer are removed, and only the packet was sent to the network protocol. And after outgoing, this network protocol carries the packet and send it back again to the network interface card, and you have those basic router and IP addressing connection. And that is. Now, let's say we go to the routing table. So this one, this is your network one. Which is your network one? What is the name of the department for network one?
Marketing, sir.
Marketing. For network two, you have development. So example, you work on a company. So all of you, since you're IT, you usually work at a development group. So already ang section A and section B. And for management group, for example, we have these are your managers, your leader, team leader, and these are your advertisers. Sila na ang may mga promotions and all, and also videos. And in this case, the interface are labeled as Ethernet A, Ethernet B, Ethernet C, and they have also different servers to have. So why do we have different server? Because these are big, let's say this one is one building, and this one is another building, and this one is another building. So in cases, this is a company, so you need to have a separate server for each services that is being offered. Now for summary, so we finished already the network hardware essentials. The difference between hubs and switches is that the hub work only with electrical signals, and these signals represent, whereas switches work with actual information. These bits combine to make frames. So that is the difference between hub and switch. So that is why hub is not used now, because hub is not really used for computer networking, but we still use this in some electronics project like Arduino, because it's easy to implement, because you have only two devices to connect, three device. But if you have more devices, much better if you have switches. Okay. So, like repeaters, hubs require power to operate, or they're sometimes referred as active hubs. However, this term isn't common because unpowered devices such as passive hubs aren't used for the same purposes. So that's why I'm looking sometimes for the power of the network device. So sometimes there are devices that they will just connect if there is somebody is going to uh, put connection on the power. But in cases, they will use the Ethernet cable, because how much is the voltage in the Ethernet cable? Do you think? So that he could operate LED. You can use Ethernet cable to light up a bulb. So it's like only 3 to 5, not really reaching maybe 3.7 volts. So in cases when you're going to connect it, you have active and passive hubs. So active, you require power, and passive is just like a extension, but you don't require to put it on the power cord, just like a normal device. As you see, it's like similar to the antenna. Have you seen an antenna divider? They have this device that you could separate or implement two connections in one input. So in that case, it's like a hub. Now, network hubs are where mainstay connecting computers land for several years. But although you can still find hubs in the workplace, and now they're becoming obsolete. A switch operation can be summarized with these steps. So a switch receives the frame, and the switch reads the source and destination MAC address, and the switch looks up on the destination MAC address in the switching table, and the switch forwards the frame to the port where the computer owning the MAC address is found, and also the switching table is updated with the source MAC address and the port information. So likewise, this is your routing table. Okay. So yeah, where is Ethernet A? This one. Ethernet B. This one. And Ethernet C. So that allows you to see the summary of the network. And also, we have discussed network interface card and MAC address. Aside from the task described previously, network interface card has the important function of giving a computer a MAC address, which is an integral part of each network interface card. So why MAC address is an integral part of each network interface card? Why do you think?
Kay Unique ang sila, sir.
Because it's like your Philippine ID that you could not have if your name is James and the other one is John. So meaning you could not change your identity with MAC address. It's going to be your distinct or unique identification. So that's why when somebody is going to enter your computer or hack you, you need just the MAC address to enter his computer. And if he allows your remote connection, he could enter every devices that you have. That's why we need more security now in our devices, so as not to get our personal information, our card number. So that's how critical is the physical address, because every device, whether you have Android, Apple, or any, you will have a MAC address. And also your network interface card. Now, if you want to see your MAC address or physical address, you could see it in your settings in your phone. But last time we have already identified this in our previous laboratory, so it's not really difficult. Now, network interface card manufacturer ensure that every NIC has a unique address, because networks don't function correctly if there is duplicate MAC address exist. So MAC address is stored in read-only memory. So meaning, what is a read-only memory? Can you erase it or not?
Hindi, sir.
So you cannot erase it. So how do you erase a read-only memory? Erase. How do you erase? ROM. By
Format,
what?
sir. Cache.
There, we have this device, electrically erasable, programmable read-only memory, or your EEPROM is the one can be erased. So you use light or electrical signal to erase, but when it is stored already in your ROM chip in network interface card, this is already static, so it remains there. You could not change it because the address is said to be burned into memory. That's it. And sometimes it is referred to as a burned in address. So if you try to examine when you're going to burn a music on a CD-ROM, right? Mag-burn ka sang CD, what happens? So, CD-ROM, whatever you burn na music or video cannot be erased by any means, but you just can destroy it like you will put some scratch on the CD-ROM, so that erases also that will destroy also the information inside, but using it for once only. So that's ROM, and it is usually 24-bit manufacturer ID. So every network device, have this identifier, and it is usually based on the organizational unique identifier, and there is also a serial number assigned by the manufacturer. Now, network interface card is your gatekeeper. When a frame arrives at the network interface card, it doesn't simply read the frame and send a packet to the network protocol. Also, it examines the incoming network frames. So aside from reading and sending, when you read and send, also you need also to examine the incoming frame in your network, and checks the frame destination MAC address to see whether it matches its built-in physical address. The NIC acts as a gatekeeper and permits inbound communication to pass through the interface only if the destination physical address meets this criteria. So if the destination physical address in the frame matches the built-in physical address, if the destination physical address in the frame is a broadcast address, and if the network interface card is operating in a promiscuous mode. Promiscuous mode. So, what is your promiscuous mode? When? What happens during this period? When the date? What's the color of your data? Sorry, LED in your network interface card. You have green, right? So if it colored yellow or amber is like yellow, meaning it's kind of busy. And if doesn't turn on, maybe there's a problem in your network interface card. Now, is it okay we have a short break, like 5 minutes before we go to network topology? Or I will continue. Try to grab some drinks or something else. I will not let you sleep in this class listening.
Yes,
Okay?
sir.
Okay, short break. And I will be back a few minutes. And I think we finish this in 12:30, and it's good. Okay? We have a short break first.
Ano kanya siya?
Okay, so we go back at exactly 12 p.m. in my clock. Sorry, in your time it's 6, right? 6 o'clock
Yes, sir.
in
6.
Philippines. Okay, okay, we start. Okay, now have you discussed this in your network one? You must have you discussed this in network one?
Wala, sir. Wala, sir, pero familiar lang oro. Ban.
So that's why I have this overview so that you will know because most of the time you will use I think this topology because in every network example there's topology. It means that the manner in which the links and nodes of a network are arranged to relate to each other. So this one is an example of what topology, for example.
This is implemented in the Cisco Packet Tracer. What do you think? Based on the topology that we have here, what is the topology of this? What do you think? Anybody?
Those stars, sir.
Start.
Oh, star, sir.
Okay,
Start.
correct. So, thank you. So you got it right. So this is a star, and you connect one. This is your switch example, and this is your computer. Okay, so you have that's how you implement in Packet Tracer. Okay, and also we have ring mesh fully connected. We have bus tree. This one is like similar to star, but it has a different implementation. This is a line, and check if I have some. Star. Okay, so now we move forward with the first type. So we have the bus topology. So bus topology uh, is shown in figure 30. So this is figure 30, and it's the simplest as is one time was one. It's one of the oldest topology that we have. So this is you can add a new computer to a network by simply stringing new length of cable from the last computer in the bus to the new machine. However, this trend is countered by some weaknesses. So during the time that they try to implement this, there is a limit only of 30. There is a limit of 30 computers per cable segment. And there's a maximum of total length of cabling is only 185 meters. And both ends of the bus must be terminated. And any break in the bus ring down the entire network. And also, it says there's only a temporary could bring one machine would affect all. So this is the problem encountered in this type of topology. The technology used in this topology are limited only for 10 megabit per second, and it is half duplex, meaning when we say half duplex, what is it? One at a
Can
time, right?
only
Ng ano, one at a time.
Yeah, send lang, either masend or receive. He cannot have both send and receive compared to full duplex. So how data travel to a bus? There are two properties inherent in a physical bus: signal propagation, and there's a signal bounce. So when a copper wire is the medium, the typical physical bus, this signal sent a series of electrical pulses that travel along the cable length and on all directions. This signal carries traveling along the cable and through any connecting devices, and they weaken when they can't be detected. So that's why when it's limited only for 30 computers, because if you connect more copper wire or this wire before, you have a copper loss. So the more wires you have, that is during the time, will also reduce the traveling of the electrical signal, because during this time there's no implementation of bit signal as compared to switches. So these physical bus have only 30 computer. What is the type of arrangement we have in this two computer? What you call this arrangement? Daisy, you call it? Daisy chain, okay? So why daisy chain? Example, it's like a petal in a flower. Then you have the connection on each end of each petal, and you have the circular one as your main connection, or your, it's like your leaves connected. So now we go to your star topology. Physical star topology uses a central device such as a hub or a switch to interconnect computers. So this is example, a basic star topology that is used to interconnect computers in local area network. And each computer has a single length of cable going from your network interface card to the central device. These are the advantages of physical topology are the following. So it's one of the much faster technologies that are used than the bus topology. It has a centralized monitoring and management of networks. Traffic is possible. Network upgrades are easier. Physical star is a topology of choice for this reason, and more with a central device. Communication options are available that are simply aren't possible with a physical bus. Because, example, a central device can be a 1000 megabit per second switch, which increases a physical bus top speed 100 times and works in full duplex mode, further increasing overall bandwidth. So you have the high capacity on using network switch and using physical star. And we have also the widely used star topology. We call it the extended star topology. So it implies this topology is a star of stars. So meaning there's a central star that is a switch, and there's another connection for a switch. So star of stars, we call this. So we could add more here, another switch, connect into another computer, and that makes this one of the term hierarchical star, because there are two or more layers of star are all connecting back to the central star. With all of these advantages, physical star, you might wonder whether there are any disadvantages. So also there are disadvantages if what will happen if the switch fail at the center.
Mano tanan sir ma-disconnect.
Yes. Now, what do we need to solve the problem if we have this? So that this one will not fail, what do we do? We have a another another switch. So in actual setup of network extended star, there is always a spare switch. In cases this going to be not able to work, there will be another switch that will be replacing the central star so that it would not be able to affect all the switches. But if this switch, example, fail, another switch will be used as connection in this case. So we have ring topology. This is like a bus in that devices that are daisy chained one to another, but instead of terminating each end, the cabling is brought around from the last device back to the first device to form a ring. So there is a, cyclical connection between them. However, to connect a local area network with a technology called fiber distributed data interface is one of was often used as a reliable and fast network backbone, which is cabling used to communicate between LANs or between switches. Now, in this case, you have this is a LAN switch that connects to building C, and you have this FDDI switch that will allow you to communicate also to building C as well as to communicate to another building using another FDDI switch. So in this case, there are all three FDDI switch are interlinked. In such cases, if example, there are some problems, the FDDI switch can be used to forward from one station to another. Unlike bus, in which data travels in all direction, it is terminated in both ends. So a ring doesn't have any beginning or end. For example, if this fails, so you could connect to another FDDI switch. So unlike bus, so what happens in a bus? Pag nadula niya ang sa tunga, what is happened? This connection disappear.
Hindi na
What will happen?
maka-receive ang sa punta pag
So the data will just be present here and this one is not failing. So that's the problem that they encountered in bus topology. But this implementation is made if only you have two devices pwede. Using Arduino, you could do this because you just turn on, turn off to computer. But in this case, it uses the problem is it uses electrical impulses. So basically, this as this computer have so many wires, so it reduce also the reliability at the end. So pag abot sang data sa punta, it's going to how many seconds possibly. So we finish with the ring topology, and now we proceed with point-to-point topology. So there are two cases. Point-to-point topology is always using radio signal usually or microwave. So or what you have in your phone now that you could P2P connection, that's point-to-point. What the NIC device you use to connect to your classmate or to connect to example I have my example I have this one, so this one, so you have I'm connecting to a laptop NIC network interface card using the Bluetooth, that is a point to point. If I also connect this to my phone, if somebody calls, I should also answer the phone by disconnecting to this lecture, and also it depends if you have devices that allows multi-point connection. In this case, point-to-point only allows one phone to another. So if you want to connect Bluetooth to your friend or to send a photo, so normally you use point-to-point topology. And if base station PLDT connected to or another base station in Iloilo, so you have a microwave connection. So this is like your business network. And what I'm saying now, we have also point to multi-point topology. It is arrangement in a central device that communicates with two or more other devices, and all communication goes through a central device. It is often used in one where main office connections to several branch offices via router. So you have this. What do you think this diagram symbolize?
Cloud
Cloud
server.
server, sir.
Okay, okay, cloud or your Internet of Things. So it depends if all of your connection is within the cloud. So we have Internet as a service and software as a service. So those are some platform. So if you access data on the cloud, you could have it in example, we have Outlook, Microsoft Outlook, or your OneDrive. So you will get a copy from your files here, and the branch office also can access it, and the branch office 2, branch office 3. Example, this is your land bank, and this is your Manila branch, this is your Cebu branch, and this is your Bacolod branch. So in this case, they all connected in the cloud, and they have their central office in another location in Manila. So that's the purpose of point to multi-point topology, where there is a private and also secured network among others. Also, we have mesh topology. This topology connects each device to every one device in a network. You can look at the mesh topology in the figure 36. So this is an example. So this is a wide area network link. Maybe these are connected via microwave or via tower. Okay. So this is also a multi-point two-point connection for the purpose of redundancy and fault tolerance. So four locations with a switch in each location providing connectivity to multiple computers. With each switch is connected to every other switch is called a full mesh. Example, this is a switch and there's another switch. So if all of them are interconnected, so you call it a full mesh. And this topology is used commonly in large internetworks and wide area network, where routers or switches in multiple buildings or towns are connected in partial or full mesh. What will be the example of a partial mesh? So if this one is erased, if I remove this would be a partial mesh. So meaning there is connection on this side, but only we cannot connect on this side. If I remove this one, that would be a partial mesh. And also mesh topologies, although reliable, but they are what? Expensive because it's used mostly fiber optic cabling for connecting building, but it has a high speed like reaching to 1 gigabit per second or 10 gigabit per second. Now for the summary for the network topology, Uh, Logical topology describe how data travels from computer to computer, in some cases as a physical bus and a physical ring. The logical topology follows the physical arrangement of the cables. In other cases, as with a star or the electronics in the central device determine the logical topology, and the network logical topology reflect the underlying network technology used to transfer frames from one device to one another in buildings. So example we have here, this is your logical topology. We have the bus. And the network technology that we could use, as we discussed before, you have Ethernet, wireless LAN, and the bus can be either a star or bus. So can be implemented using physical bus, although this topology is now obsolete. When a logical bus is implemented as a physical star using a wired Ethernet, the center of the star is an Ethernet hub. Whatever the physical topology is, data transmitted from a computer is received by all other computers. Now for wireless LAN, local area network, mostly we have it by a star. So wireless LANs use a physical star topology because they connect through a central access point. However, one device can transmit at a time because this is a bus topology, and all devices hear the transmission, so a wireless LAN can be considered as a logical bus topology also. Now for the ring, we have a token ring, and this is star. Why we call token ring? So token ring networks are used to as a central device called multi-station access, or MAU. It's electronics form a logical ring so that data is passed from computer to another in order until it reaches the destination device. So there is a token that is being passed from a computer to another until it reach the destination. So you pass one token to this computer. We have a ring. Okay, so you pass one token to this device, and you pass one token, and every token you pass, so you could be able to go to the computer that you want to. So before you can go, you need to pass the token on every ring switch. And also we have the fiber distributed data interconnection. So you have also a ring. So it's discussed, FDDI are connected in physical ring and data processed from one device to another. Also, by the way, this one also can be implemented in star. So you have star topology. So you pass one token on this computer, and you pass one token, and you could connect. Okay. And we have switch Ethernet or star. The switch logical topology is used to using a physical star topology running internet is by the most common topology technology combination now, and likely will be well into the future. The switch technology creates dynamic connection on our circuits between two devices whenever data is sent. This topology is sometimes considered as a switch point-to-point topology because a circuit is established between two points as needed in the to transfer data, and then the circuit is broken when it's no longer needed. So I think that is the end of our lecture. Any more questions with your assignment and task?
None, sir.
Okay na, sir.
None,
So
sir.
please prepare for your test. I'll give the outline of the questions that will possibly appear on the test tomorrow. And maybe we'll have it like 25 items, multiple choice for the midterm. And thank you for attending the class. And we are finished already.
Thank you, sir.
Thank you. Goodbye
Thank
to
you,
all.
Thank you, sir.
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 Bye-bye,
Thank
sir.
you, sir.
Sir.
Bye.
Thank you, sir.
Thank you, sir.
Goodbye.
Thank you, sir.
Thank you, sir.
Sir, pwede ka pa mangkot.
Yes.
Ang Module 6 bala sa raw nang din to mapasa, sir.
Module 6.
Ay, hindi na to gali, sir, mag-pass. Gin-example mo lang to, sir. Gin-demo mo lang.
Ang Module 6, you submit it by group.
Oo, sir, pero diin bala mapass, sir. Ako kay why ka pa man ka-post, sir, sa Google Classroom.
Sa Module 6 na submission.
Oo, sir.
I-post ko lang kayo. Wala pa ako ka-update. No.
Okay, sir.
Sige,
Thank you,
thank
good.
you.
Nang sir, may ask mo, sir.
Yes.
Nang regarding bala sa module 2 kag 3, sir, di ba nang may sa instruction to nga ang MAC address sang bala Windows computer kag ang MAC address sang duha ka devices bala virtually, sir, sa pakitracer ipakita kinang tatlo, di ba, sir, no?
Ang command prompt ipakita, i-print screen lang.
O, sir, ang iya ka ang ginagamit kinamo
Ah,
nga physical bilang ang duha ka amo na, sir, ang command prompt.
ang sa dere na side kag sa dere
O,
ipasaka dyo
sir.
lang ang ano. Oh.
Sige, sir, thank you.
Oh.
Thank you, sir.
Thank you. Goodbye.